Alkynes are unsaturated hydrocarbons having the general formula CnH2n-2. So using this general formula, if we look at the first three alkynes, we get ethyne having the molecular formula C2H2, and that is the abbreviated or the condensed formula in which the two carbon atoms are linked to each other by a triple bond. Similarly, for propyne, we have the molecular formula C3H4 and the condensed formula. For butane, the molecular formula is C4H6, and that is the abbreviated or the condensed formula. Now, what type of isomerism is possible in alkynes? Let's take an example. We have butane. This is but-1-ine, since the triple bond is present at position 1. So in this case, we have 4 carbon atoms, and there is 1, 2, 3, 6. 6 hydrogen atoms. So this is the structure of but-1-ine. If we write another structure, we shift the triple bond to the second position. So we get but-2-ine. In this case, we have 1, 2, 3, 4 carbon atoms, and we have 3 plus 3, 6 hydrogen atoms. So in both the cases, you observe that the molecular formula remains the same, but there is a difference in the structure of but-1-ine and but-2-ine. So this means they are isomers. Now, what type of isomers are these two? Let's recall. We have two types of isomers. The first one is chain isomers. These are the compounds having the same molecular formula but different arrangement of carbon atoms in the straight or branch chains. The second type of isomers are position isomers. These are the compounds having the same molecular formula but different position of functional groups in the structures. Now, if we look at the two structures that we had obtained, in this we observe that there is a difference in the position of the functional group. The triple bond in this case is the functional group, and we see that in the first case, the triple bond is at position 1. In the second case, the triple bond is at position 2. Since there is a difference in the position of the functional group, so these isomers are known as position isomers. Let's take another example. We have pent-1-ine. In this case, the triple bond is present at the position 1, and we get C5H8. Now let's try to write another structure having the same molecular formula. We shift the triple bond to the second position. Again, if we count the number of atoms, we have 5 carbon atoms and 3, 4, 5, 6, 7, 8. 8 hydrogen atoms. Let's try to find another structure. Now in this case, we get another structure. We keep the triple bond intact, that is at the first position, and we move the methyl group. We bring it to the third position. So in this case again, let's count the number of atoms. We have 1, 2, 3, 4, 5. 5 carbon atoms. And 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen atoms. So we observe that the three have the same molecular formula but different structure. That is, different structural formulae. So what type of isomers are they? So let's take 1 and 2. Let's number them. 1, 2, 3. So for 1 and 2, if we compare, we see that there is a difference in the position of the functional group, which is the triple bond in this case. So 1 and 2 are position isomers. Now let's compare 1 and 3. So if we take 1 and 3, we see that the functional group remains at the same position. That is, it remains at position 1. But the methyl group has moved. From the straight chain, it's now at position 3, that is in the branched form. So whenever there is a difference in the arrangement of the carbon atoms in the straight or the branch chain, such isomers are known as chain isomers. So 1 and 3 are chain isomers. Now let's compare structure 2 and 3. In this you observe that the functional group has changed its position. In the second structure, the functional group, that is the triple bond, is at position 2. In the third structure, the functional group is at position 1. So these two have the difference in the position of the functional group, so they are position isomers. Also, if we see the carbon atoms, in the second structure you see that the 5 carbon atoms are present in the straight chain. But in structure 3, 4 carbon atoms are in the straight chain and 1 carbon atom is present in the branched form. So there's a difference in the arrangement of the carbon atoms in the straight or the branched chain. So these two are also chain isomers. So structures 2 and 3, they are both position and chain isomers, because there is a difference in the position of the functional group and there is a difference in the arrangement of the carbon atoms in the straight and the branch chain. So the type of isomerism which is possible in alkynes is both chain and position isomerism. What type of isomerism is shown by alkynes? So if we take an example, we have pent-1-ine, pent-2-ine and 3-methyl-but-1-ine. In this case also, if we count, we have 1, 2, 3, 4, 5 carbon atoms and 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. So the 3 have the same molecular formula but different structures. 1 and 2, if we compare, we see that there is a difference in the functional group, that is, there is a difference in the position of the triple bond. So 1 and 2 are position isomers. 1 and 3, there is a difference in the arrangement of carbon atoms, so they are chain isomers. And if we compare 2 and 3, there is a difference in both the position of the functional group and there is a difference in the arrangement of the carbon atoms. So structures 2 and 3 are both chain and position isomers. So the type of isomerism which is possible in alkynes is both chain and position isomers. Let's try to find the structure of ethyne. The common name of ethyne is acetylene. So we generally write for ethyne, we have a triple bond between the 2 carbon atoms. Now we have to fit 2 hydrogen atoms, 1 hydrogen atom on each carbon. We know there are electrons on both hydrogen atoms. Since like charges repel, so the 2 hydrogen atoms try to be at the maximum distance away from each other. If we place the hydrogen atoms like this, now do you think they are at the maximum distance away from each other? Well, let's try to place them separately. What if we place them like this? So in this case, you see that the 2 hydrogen atoms are at the maximum distance away from each other. So this is the farthest position for the 2 hydrogen atoms and this is the structure of ethyne. So let's observe the structure again. These are the 2 carbon atoms. They are linked to each other by a triple bond and the 2 hydrogen atoms take this position such that they are at the maximum distance away from each other. So even when we rotate it, we see that the structure remains the same. So this is the structure of ethyne. The angle between these 2 bonds, that is this triple bond and this single bond, is 180 degrees. Similarly, this angle is also 180 degrees. Such a structure is known as a linear structure. So the structure of ethyne is linear.